What is an abstraction barrier? This is a concept from structure and interpretation of computer programs. And in this episode, we're going to talk about what it is, why to use it, and the limits of its usefulness. My name is Eric Normand, and I help people thrive with functional programming. So like I said, this is a concept that I was first introduced to in structure and interpretation of computer programs. I imagine it goes back further than that, just because it's kind of a natural concept to develop. And what it is basically is, instead of doing some complex operations inline, you move them, you extract them out into a function, you name that function, and now you have a barrier where you don't really have to think about the internals of how this thing gets calculated. You have an operation that's got a nice, clear, meaningful name that you're working on. And so if you do this with a data structure, so in structure interpretation of computer programs, they're using scheme. So the data structure they use is just basically these const cells, which are just pairs. They're like tuples, but always pairs. And so they're building these intricate little data structures out of them. For instance, in one example I can remember, they build an associative data structure where you can put keys and values and replace keys and values and look up keys by values. And it's all just const cells. It's all just pairs. And so it's deeply nested stuff. And so they build operations like add a new key value pair, find the value for this key, right? These are operations, and they're giving them nice names because when you look at the code, it's just like, okay, I have to explain this. In scheme, to get the first element from a const cell, you use a function called car, C-A-R, and to get the second element from a const cell, you use a function called cutter, which is C-D-R. So you would put these things like, okay, get the first element in the car of the cutter of the cutter of the car of the car, and that will give you the element you're looking for. So you're looking at these operations. They're not very meaningful, except it's like first, second, second, first, first, first. But it's just hard to wrap your head around what is that actually doing. It would be really nice if someone gave it a very meaningful name, like find value given a key, right? Or just like get, something like that. And so you do this to help your mind to encapsulate, to put a barrier on the meaning. You can say, I don't have to think about this anymore. There's 3 operations I'm going to do on these things. I have them well named. I don't have to go digging around myself and remember how to get a cutter, how many cutters I need to get the value of something. Okay, so this is the what and the why. It's because sometimes you've got these deeply nested things, and just for your mental capacity, it's hard when you inline those to be able to reason about the code. And so what's happening is you're just doing that basic naming operation. You're naming this thing that you're going to use a lot. And so you're taking what are meaningless operations like car and cutter. They have a meaning, but the level of meaning is very low, and you're elevating that function into a new level based on the name. So the name is something much more meaningful at a higher level of meaning. But it's not data hiding. It is different from data hiding in one very important respect. It's still all there. It's still transparent. If you want to pierce your abstraction barrier, go right ahead. You can still map over it. It's still a list. It's still const cell, so you can still call car on it, right? You are not forced to use those abstraction barriers, those defined operations. Some people say that's a fine line because you're saying you should, and there's some arguments like, well, if this data structure escapes, no one's going to know to use those things, or they're going to have to use them anyway, so you have to give them to them, and all that is true. I don't want to argue about that. What I just want to argue is that there is this very important difference, which is that you don't have to use those operations. It's not like data hiding in an object-oriented system where you've got all this private stuff, and then the three operations that you want to do on it are the public methods, and you don't know how it's implemented, and you're supposed to not care, and you're supposed to not even be able to mess with that data. Okay, you can mess with the data if you want to. And this is important because you want to be able to move through those levels. Now, the trouble is const cells are not a very rich data structure. And they basically suck, okay? I'm just going to say it like that. They're really neat. They're complete, like you can build trees and lists and a whole variety of data structures with them, but they're not self-describing, so you don't know what you have. You just have this, if you printed them out, there'd just be parentheses with stuff inside, and they don't have, they're not human readable, so, they are, but not very. You need to know what the different levels of the parentheses mean, so you need some out-of-band communication. It's not self-describing, and so a lot of problems that we have with these data structures are solved by having self-describing names like a hash map where the keys are strings, and so you can have a nice name, right? So before you had to build this associative data structure, now you can have a data structure that says, hey, I am an associative data structure. I have the curly braces in JSON, and my keys are strings, and my values are also some value that you can understand. Okay, this is amazing, right? Because now we don't need to have these abstraction barriers to do the same thing, right? So a lot of problems are solved just by having better data structures. Okay, you don't need the abstraction barrier. It removes a whole slew of reasons for needing abstraction barriers, especially around these intricate data structures. There's a thing where, if you have public-facing data, you shouldn't really use abstraction barriers. Right? You should design that data to be easy to consume, easy to produce, not necessarily using specific operations. You want someone to be able to type in this literal JSON and it be correct. You don't want something where you need some complex operations that they have to define and basically copy from your code base in order to build the thing up. You don't want that. You want a public-facing thing. You want very clear names, and when you design them and you put it out into the world, those names are a commitment. They're a commitment on your part as an implementer that you're going to honor those names. If you send me this JSON to my API endpoint, I'm going to read it, and I'm telling you what this key value, this key means and what the value, how I'm going to interpret the value. That is a commitment that you're making. And so the self-describing nature of it is really important, and you shouldn't rely on an abstraction barrier. However, we also use, besides using it for public-facing data, like a public-facing kind of schema or spec, we also use data structures internally in our software. So if you need some intermediate index of something, you'll use a hash map to index it. And sometimes when you make the index, well, you want to keep track of when you added the thing and like when was the last time you accessed it, and like so you've got all these other bits of information that you have to maintain, and sometimes you want to maintain the order, and it's in a hash map that doesn't have order, and so you want to keep them in sync. Well, now you're starting to talk about this intricate data structure nested in other data structures. Like at some point you're back to the same problem that you had with Kant cells, which is deeply nested. You're forgetting how many levels you have deep, and you're inlining all these like cutters and cars, except they're not cutters and cars. They're like, oh, get this internal map, and inside of that get this thing, and then that's going to give you a map with, and then you need the value out of that map. Like it's all deeply nested again, and it's easy to get wrong. When you add a thing to the index, there's like 5 things that you need to do, and yet they have to be right, and you want to make it easy to get those things right. And so, and you're gonna, it's like you're doing 5 things. It's probably 5 lines of code. You're repeating that everywhere. You want to like dry this up, you want to take that duplication, put it in a function, give it a good name, and all of a sudden you're doing abstraction barriers again. Okay, it's just the way it is. It just happens when you have these complex things. Now, like I said, this isn't for something that's going to go external. External, you want it to be nice and clean and neat and human writable, human readable. But when you're working internally, sometimes you need an index that's like really tricky and complicated, or you need some data structure that's like super weirdly nested. And so you want to start extracting out all those operations again. Now, I want to say another thing. Like a lot of times, and I think in SICP it says this too, and I disagree with it. I disagree with SICP. That's structure and interpretation of computer programs. One of the reasons they give for using abstraction barriers is so that you can change the data structure if you need to. And I think that this is just so overused. We write code today more complicated than it needs to be, because maybe one day in the future we might want to change it. And I just think that that's wrong. Why complicate your life today for something that might or might not happen in a way that you can't even predict? Okay? So if you know how it's going to change, if you're saying, look, I know I'm going to swap out my database, in 1 year. I'm using this one database now because I can't afford the one I really want. And when my company does better, I'll have an income and I'll be able to pay for that database I do want. So I want to be able to swap it out easily. Okay, sure. If you've got some plan for changing it and you don't want to have to change all the code again, right? Sure, fine. If that's part of your plan, you need to be able to change it. Yes, put some kind of indirection in there. But if you're just doing it like a just in case, like maybe we'll need it, no. Do not do that. Okay, so I people say it, but I think you should not put abstraction barriers just because you might want to change it. You should put abstraction barriers to make it clearer what's going on, especially when you got these intricate, tricky things. It's hard to get right. You shouldn't use it for public-facing data. That should be well-designed, clean, simple, something that another person could write code to generate and not rely on your perfect implementation of all these operations. But you should use it for these intricate data structures that never leave. Like these indexes aren't meant to be printed out and sent over a wire. They're meant to be like stored in memory for some algorithm or something you're doing on it, where you need like constant time access. All right, so abstraction barriers, I'm going to recap real fast. Abstraction barriers are simply taking operations that you're doing on some data structure or some piece of data, and you're repeating it, and it doesn't have enough meaning, so you extract it out and give it a name. Okay, and if you do that for if you can count all the operations you're doing on this data structure, let's say there's 4 of them, you extract all of them out, give them good names. Now you no longer have to go down into the data structure and manipulate things, at the low level. You can operate at a higher level. That sounds like a good thing to me. It differs from data hiding in that you can always pierce the barrier. You can look at it and it's just raw data. Okay, it's not some encapsulated class or object that just has some bespoke methods on it that you can't see how it's implemented inside. Okay, you can pierce it. Hash maps and other very much more descriptive data structures that we have in the modern languages. These are, because they're literals, because they have descriptive names, they have more well understood properties, like an array has certain order to it. You don't need to use these like a const cell, which has almost no meaning behind it. You've got higher level stuff, self-describing. You have literal versions of it, so you don't have to even think about constructors so much anymore. It's much nicer. But we still build up these intricate, highly nested things for internal use. And I believe that abstraction barriers, as I've defined them here, are really useful for that. That you want to be able to be operating at a higher level, even though it's this like really intricate, turning of machines and stuff. And it's just normal. We let me say it in a different way. Hash maps, descriptive names and stuff remove a huge need for the abstraction barriers. But we reinvent the problem because we have all these really highly nested, intricate data structures again that are now made of hash maps and vectors and sets and whatever else we have. They're still there. They're just not const cells anymore. They're just some other thing. And I've seen so many messes in languages like Clojure that use these data structures a lot. When they start getting nested, people forget what they have. They start coupling code together because they're using they're coupling the where a value lives deeply nested in this map because they are using some path into the nested data structure with the operation, what they want to do. So the where and the what they want to do get coupled together. And having a little bit of barriers when you have a mess, like it's like having little bins to put all your stuff in instead of having in one big bin. It's just a way to organize it and a way to keep a little bit of sanity when things start to get into a mess. All right. So this has been all about abstraction barriers. This might be a tad controversial. Abstraction barriers shouldn't be used all the time. I'm not saying that, but I still think that they're really useful, especially when you've got nested data structures and you're starting to get into a mess. Okay. If you like this episode, please subscribe. Go to lispcast.com/podcast. There you're going to find all of the past episodes. So listen to the one where I talk about building your interface first. Listen to the one where I say just use data. I really think that these are subtle issues, and it requires, it's not as simple as like use this, don't use that. You gotta allow for some subtlety in there. So you'll find all the past episodes with audio, video, and text transcripts. You listen to it however you want, watch it, or you can even read it if that's how you like to do it. You can also subscribe there. You'll find links to subscribe in the various platforms, and also links to find me on social media. So that's email, Twitter, LinkedIn. Get in touch with me. If you disagree with me, I would love to have a discussion about this, because I think it is a bit controversial, and I'd love to hear like more arguments for and against. So if you've got one of those, or you've got a question because I didn't go over something clearly enough, come on, just hit me up, and we'll talk. Awesome. My name is Eric Normand. This has been my thought on functional programming. Thank you for listening, and rock on.